Hello dear students. So today we will discuss the questions based on how to write the formula of coordination compounds and how to write their nomenclature. So those students who are having still some confusion, they can clear their confusion, right? So the question was given that write the formula. So first we will write the formula for these coordination compounds. First compound given to us is Tetraamineaquachloridocobalt 3 chloride. So first of all, we have to predict that whether the complex is cationic or anionic. Since chloride is given and it's to the right side, so chloride is negative ion and it's simple. So this shows that this complex will be cationic complex. Okay. And by rule, we have to write the name of the complex first. So how to write the name of the complex? First we will write the square bracket, we will draw the square bracket, then we will select the central atom. So central atom in this complex is cobalt, so CO, C capital, O small. Then after this followed by ligands, and ligands, they are to be represented alphabetically. So as you can see, it's tetraamine. So amine, tetraamine means 4 times, amine stands for NH3. After this, it's aqua. Aqua stands for water. So water will be there. And then can be covered within parenthesis. And then after this, chlorido. Chlorido means Cl. Right? So this will be the complex. Then close the square bracket. And then chloride outside. Now how many chloride will be there? So that has to be checked as per its oxidation number. We have to relate and we have to find the charge on the complex. How that charge can be calculated? So first of all, as in this case, the oxidation state of central atom is given. The oxidation state of central atom to CO is plus, it's plus 3, right? As given in 3 Roman, right? Now amine. So you have to remember that amine is neutral. So that means it will have 0 charge. In the same manner, water is also neutral. It will have 0 charge. And chloride. Chloride will have -1. So now within this this coordination complex, plus 3 and -1. So what will be the charge left? So plus 3 -1 means it will have plus 2 charge over here. So the complex will have plus 2 charge. So in order to neutralize this, how many chloride should be there? So there should be 2, right? Is it clear? So this will be the formula of the compound. Once again I am writing final CO NH3, how many times? 4 times, then H2O, and then Cl, square bracket close, Cl2. So this will be the formula of this complex. Okay. Now let us take another example. The example given to us is dichlorido bis ethane 1,2 diamine cobalt 3. So this is complex, means coordination complex is given, no counter ion is given to us. So we will write it for starting with dichlorido. So first we will draw square bracket, then again cobalt is the central atom. So we will write cobalt. Then after this followed by ligands. So dichlorido. So dichlorido means Cl 2 times. Then bis ethane 1,2 diamine. As you know, this bis term is used for the complex bidentate or polydentate complexes which contains ditritetratom within themselves. So bis stands for 2, and what is the symbol for ethane 1,2 diamine? It was En. So 2 times. This is the complex, right? Dichlorido we have written, then bis ethane 1,2 diamine cobalt, then square bracket will be closed. Now what should be the charge on the complex? So charge again, since oxidation state of central atom is plus 3, so we will write it as plus 3. Chloride has -1 into 2, so it comes out to be -2, and then En is neutral. So what should be the charge left? So it is plus. That means this is in ionic state. Okay, cationic complex. So whenever complex is written, generally in the nomenclature we can write ion towards end. Okay. So finally the name of the complex will be COCl2 En twice, square bracket close, and positive. This will be the formula. I hope you are getting this. Now next, that is third one. Third one is tetracarbonyl nickel 0. Now the tetracarbonyl nickel 0. So again there is no counter ion. So we will write simply square bracket, nickel is the central atom. So we will write nickel first and then tetracarbonyl. Now what's the difference? What is carbonyl? Carbonyl is just CO. So within bracket we will write C capital O as well as capital, right? Not cobalt. So don't get confused between carbonyl and cobalt. Cobalt has C capital O small, whereas carbonyl has C capital O as well as capital. It's carbon monoxide, right? So nickel and then carbonyl, tetracarbonyl. So tetra means carbonyl will be 4 times and nothing else, and we will close this. So this will be the coordination complex. Now what should be the charge on this? Since oxidation state of nickel is 0, so what will, and carbonyl has 0, so there will not be any charge. Do remember that all the carbonyls, in all carbonyls, whatever you will come across, the central atom will have 0 oxidation state. Okay. So this was the third example. So finally it can be written as square bracket NiCO4. This will be the final complex. Right. This is how we write the formula of the compound. So this was the first example. The next example is write the IUPAC names of these coordination compounds. Now in the previous case we have written the formula. Now we will write the names or IUPAC names of coordination compounds. So starting with the first one, in this case we have got the cation, ion. Counter ion is not there. So cation is there. For this cation, the rule says that first of all we will write the ligands, right? If the complex is cationic, so we will select the coordination complex first. If the complex is anionic, then we will write the cation first and then followed by anion. In this case it's simple ion, so we will select the ligand. So it's chlorido, then ethane 1,2 diamine. So we can write it as dichlorido, then it is ethane 1,2 diamine. Since its di comes within this, its name, so we will use, for 2 we will use bis, and it has to be in continuation. Bis, then ethane 1,2 diamine within parenthesis. Ethane 1,2 diamine, and then cobalt, central atom, and then its oxidation state. So what will be its oxidation state? How to calculate oxidation state? So for example, the complex given is COCl2 En twice, right? This is the complex and positive charge. Now let us calculate oxidation state. So we will put it as X plus, now chloride has -1 charge into 2 plus En has 0 into 2, and it will be equal to +1 because positive charge is there. Now find out X. So X minus 2 equals to +1, and X will be equal to +3. So that means the oxidation state of central atom in this complex will be 3. So it has to be written in Roman. So finally the name of the species is bis-ethane 1,2 diamine cobalt, and then oxidation state will be 3. And you can also write ion because it's ion, so you can write ion, not cation, just simple ion. So this will be the name of the complex. I hope it is clear to you. Let us take an example of the next complex, that is K3FeCN6. So this is a complete coordination compound as it contains cation as well as anion. Now in this case, cation is simple and anion is complex. So the name has to be written in the same manner, that is first cation. And cation is potassium, so we will write potassium. Then we have to leave some space before we start the complex. Now the name of the complex has to be written in the same manner, that is we will first of all we will select the ligands in their alphabetical order, followed by the central atom and then its oxidation state. So ligands given to us is only one ligand, that means it is homolactic, hexacyano. So after leaving some space, hexacyano, then name of the central atom. Whenever the complex is negative, the name of the central atom by rule it must ends in 8. And for iron we will write the term that is ferrate. Right, all this we have discussed. Ferrate, and then its oxidation state. So what will be the oxidation state? So oxidation state can be calculated as +1 for potassium into 3 times plus X -1 into 6. -1 into 6 equals to 0 because it's neutral. So +3 plus X minus 6 equals to 0. So X comes out to be 3 plus 3. So that means 1, 2, 3 in Roman we have to write. Right? So this is how, this will be the name of the complex. Okay. Once again I am writing it, potassium leaving some space, hexacyano ferrate and 3 the oxidation state. This will be the name of the complex. Right? Now the third example, that is NaAgCN twice. Right? This is the complex. So name of the complex, again first of all analyze the complex. It is simple cation, it contains simple cation and complex anion. Right? So how to follow? How to write the name? So sodium has to be written first. So sodium. Then leaving some space, it will be 2 times dicyano. Since this is complex, the complex is anion, so the name of the central metal will be written, it ends in 8 and its Latin name is arginitate. Arginitate, right? And then oxidation state. So whatever is the oxidation state, how to calculate that? So for sodium, let's try it here. For sodium it will be +1 plus X for silver, and then it will be plus minus 1 into 2 equals to 0, right? So plus 1 plus x minus 2 equal to 0, and it comes out to be x will be equal to, finally it will be plus 1. So that means the oxidation state of silver or argentate will be 1. So sodium dicyanoargentate is the name of the complex. Okay. Now some more examples were given. This was from exercise. Write the formula for the following coordination compounds. Again, we have to write the formulas for the coordination compounds. The first one is, it's given to us tetraamineaquachloridocobalt 3 chloride, already done. Potassium tetrahydroxozincate. Now this is the another example how to write the formula. So potassium tetrahydroxozincate. So first analyze whether it is complex cation or complex anion. So cation given to us is simple, it's potassium. So how to write? So the second one, first we have already done. So first we will write potassium. So I am writing K, no need, how many times, then followed by square bracket, because the complex has to be always written in square brackets. Tetrahydroxo. So tetrahydroxo, and then zincate, zinc. So within square bracket we will first of all write zinc as the central atom, and then tetrahydroxo. Hydroxo stands for OH. How many times? 4 times. Zincate 2. So this will be the complex, and now oxidation state of central atom is 2. So what should be the charge? So it comes out to be 2. OH has minus 1 into 4. So minus 1 into 4, that will make minus 4 in total. So plus 2 and minus 4. So that means the charge should be minus 2. And in order to neutralize this minus charge, we require how many potassium? 2. So the final name of the formula of the complex, that will be K2ZnOH4. This will be the formula. Okay. Then moving to the next one, the third one, it's potassium trioxylato-aluminate 3. Again, the complex is anionic and potassium is there. So simple cation is there. So the main formula of the third can be written as, first we will write K for potassium, then followed by square bracket, find the central atom, it's aluminate, that means aluminium. Aluminium is there. Then trioxylato. Now trioxylato is C2O4, right? 3 times. This will be the trioxylato, and then square bracket close. Okay. Now again we have to find that how many potassium ions should be there. What should be the number with K? So for that you have to remember aluminium has given, it has plus 3 oxidation state, and this oxalato has minus 2 charge, oxalate ion, if you remember, right? So minus 2 into 3, that comes out to be minus 6, right? Minus 2. So plus 3 on this, minus 6 on this side. So which equates how? What will be the difference? So it will be 3. That means on this side it should be plus, it comes out to be minus 3 charge. And then in order to neutralize that minus 3, how many potassium are required? 3. So finally, the formula of the complex is K3Al. I can also write this oxalato as OX. One and the same thing, 3 times. This can be written, or C2O4. Okay. So this is the complex. Then going to the fourth one, dichloridobisethane 1,2 diamine. This we have already discussed. Then tetracarbon and nickel. This we have already discussed. Okay. So these were the formulas of some of the complexes, how to write the formula. I hope you will remember this now. Now you can check this. These are the complexes. Okay. Then next, now write the names of the IUPAC names of the following complexes. So IUPAC name of these complexes. First complex, it's PTNH3 twice ClNO2, right? Neutral complex is there, no cation anion is there. So that means we have to select the alphabetical order for the complexes. So it is diamine chlorido, and this is nitrito N, because the linkage is through N. This is ambidentate ligand. So we will write it as first one, diamine chlorido, then nitrito N, and it will be platinum. Platinum in the same manner it has to be written. Platinum, then oxidation state. So oxidation state, that comes out to be platinum X, X for platinum, plus amine has 0 charge, so 2, plus -1 for chlorine, plus -1 for nitrito. So it will be X minus 2 equals to 0. So X comes out to be plus 2. So that means in Roman we will write 2. This is the oxidation, and this is the oxidation state. And finally it is diamine chlorido nitrito N platinum 2. Okay. Now the next example is potassium, then chromium oxalato, trioxalato, right? So how to write? So second one is potassium, chromium, C2O4 thrice. Just we have written it from its name, we have written the formula. So now how to write? So again the complex ion is anionic, whereas cation is simple. So first we will write the cation, that is potassium. Then in this case this is bidentate ligand, so we will leave some space for the complex counter ion, that is complex anion. And because it doesn't contain ditri within its name, so we will not use base stress term, rather we will use tri, leaving some space, trioxalato, and then chromate. Why chromate? Because it's a anionic complex, so the name of the central atom will end in 8. So potassium trioxalato, chromate, and then oxidation state. So what will be the oxidation state? So oxidation state for potassium, how to calculate? Potassium is +1 into 3 plus chromium X plus -2 into 3. So it comes out to be 3 plus X minus 6 equals to 0. So X comes out to be +3. So we will write 3 in Roman. So this will be the complex potassium trioxalato chromate 3. Okay. Now the next one is CO Cl2 En twice Cl. So this can be named third one. Again check this species, that the complex ion is cation and the counter ion is simple anion, right? Chloride. So we will write first cation. So complex name will start with alphabetical order of the ligand. So it is dichlorido, bis ethane 1,2 diamine. So we will write dichlorido, then bis ethane 1,2-diamine, parenthesis closed, right, and then cobalt. Everything has to be in continuation. Cobalt, then oxidation state, and finally leaving some space, counterion, chloride. Now what is the oxidation state in this case? So for cobalt, let us take it as X plus -1 into 2 for chloride, plus En has 0, so 0 into 2 plus -1 equals to 0. So it comes out to be X minus 2 minus 1 equals to 0. X will be -3 and X comes out, sorry, X will be +3 finally. So again the oxidation state will be written in Romans like this. So this will be the complex. Dichlorido bis ethane 1,2-diamine cobalt 3 chloride, leaving some space between the ion. Okay. Now the fourth one, fourth species now. Fourth species is CuNH3 5 times CO3 and then Cl. So we will start with, because the complex is cationic and counterion is simple anion. So starting with the complex. Complex contains two ligands, that means it is heteroleptic. This one is amine, this one is carbonate. And as you know that the name of the negative ligands that will end in O. So it comes out to be carbonato. So we will start with amine. So how many times? 5. So it will be written as penta amine, then carbonato, and then cobalt, followed by oxidation state, and then leaving some space we will write chloride small. Okay. Now how to calculate oxidation state? So put it as, for carbonyl for cobalt we will write X plus amine is neutral, so into 5 plus, yes, carbonate ion has -2 charge, so -2 into 1 plus chloride has -1. So again X minus 3 equals to 0, X comes out to be +3. So again we will write in Roman 3. I hope now it is clear to you. Okay. Then the last one, that is the fifth one. So fifth species, it is HgCOSCN 4 times. First, it's anionic complex and cationic, simple cation. So we will write mercury. Then we will leave some space, and then it is thiocyanato. So it will be tetra 4 times, thiocyanato and isothiocyanato. These are again ambidental ligands, so it will be thiocyanato, and then it will be cobaltate, and then oxidation state. So mercury, then leaving some space, tetra thiocyanato cobaltate. How to calculate oxidation state? So mercury will have +1 plus X for cobalt, and then thiocyanato has +-1 into 4 equals to 0. So X comes out to be +3. So oxidation state of cobalt will be +3. So these were some of the examples. Rest examples you can practice